So for a while, I've always kind of found the concept of a quasi star very interesting. I didn't even really think much that that a black hole could exist within a star, while it being so big that it's not like really necessarily large enough to consume it. It's kind of interesting to think. Maybe there really are forces that really can withstand black holes' gravity in a lot of ways, but maybe there's more to the universe than we think too. And so it leads me to think, if quasi-stars really do still exist, where would we find them? Well, obviously they'd be much bigger than Stephenson 2-18. As of right now, it's the largest star we know of. And a quasi-star would have to exist like where it's very illuminated. Now, I'm not an astronomer by definition, but basically from what I understand, basically when a star is very illuminated, it's usually very large. And I mean, now they have found stars that are very, very illuminated, but they're very, very small too. So really, just because the size of the illumination is very bright does not necessarily mean the star is even bigger than it really is. But this could be at the same time kind of a misdirection. If we just have to keep our eyes open basically. If we were to find a star that's like super, super big and super, super hot, we could find a star that could very well be the size of a quasi-star. Now, I wouldn't be surprised, and I'm not saying they exist right now, but maybe we just haven't found one yet. Like, possibly, there's definitely probably stars way bigger than we could even imagine. I mean, here's something else to think about. Stars over time can even gain more mass, and they obviously burn it off too. But depending on the kind of star, depending on its properties, depending on what just happens to it in its star cycle and its own uniqueness, could very well determine if the star itself still exists or what kind of nature it becomes. Now, I do think at the same time it's very possible that such a star could exist because we obviously haven't discovered everything yet. But more or less at the same time, though, the fact that we found black holes that are significantly bigger, I think it was ton 680 or something like that. It's not like all one word, it's like a space in between there. Somebody correct me if I'm wrong, but like the star is the black hole was so big and the gravitational pull was so large and strong that it probably would have been close to I think it was a quasi-star if I remember correctly. If maybe even more. I had to double check. But basically, I mean, and the thing with black holes is they do merge over time with other black holes, so it's very possible that they could have just, they still form galaxies everywhere else. But I wouldn't be surprised that just because we do know that black holes exist, we do know like what they are, and we do know like kind of how they work, sort of. There's enough evidence to go off of that there very well could be evidence that, they could have been from very large stars. Because after all, in order for a black hole to form that we know of, it's an implosion of some kind. Not just as far as like a supernova, like for example, if a star blows up, then it explodes. But it's like if a star was to implode on itself, you're creating gravity that's so strong and so it inward itself, and now even light couldn't even escape it, technically. And at the same time, there might be some things that could probably escape it, but at the same time, though, with the way how fast the universe moves, and it really depends. But it's basically probably just another dimension to a portal to another dimension, and it basically probably means it's like the birth of another universe or even other dimensions as they move along and create more stuff. Because the universe, from what we understand, everything's made of energy, and it's just basically progress in the long run. Everything just finds a way to renew itself, and it just leads somewhere else. There's obviously so much we don't know, and I wouldn't be surprised that quasi-stars might have been doing that even when they existed. Because if like black holes existed like in its core and this thing was burning off energy, because like basically the bigger the star, the more energy it's using, so it has a shorter life cycle as well as how fast it's burning too. So if it's a very illuminated star at all, which it would be in this case, I mean, it'd be like what they said, it was like at least 10,000 Kelvin before it cooled down at like 3,000. But the rest of the energy would eventually, if it didn't get sucked into the black hole at first, then eventually it would find a way to get sucked into the black hole at some point, So basically, the energy is going to go somewhere, but basically it's such a big star, you know, it's basically just creating like different star mass and all that, and nebulas, and over time it eventually just turned into stuff, you know. I mean, basically, aside from stars just creating illumination and heat and radiation, basically big stars only exist so that way they can create like a gravitational force that keeps like gravity sort of, so that way it can keep objects around it, and it can create like a light source, as well as holding like a galaxy together, you know, because there's like hundreds of thousands, billions, trillions. There's probably even more in our galaxy than we think of, for example. But where would we find a quasi-star in our galaxy? I don't think it's out of the ordinary that it could be out there somewhere. If I remember correctly, we're actually at like one of the most outer edges, or one of the most outer edges of this galaxy. So we're not really like in the center more. And so there's probably a better chance that that's probably where you might find, or then heck, you could even go to like IC 101. What was at one point the largest known galaxy, but now there's been other galaxies that have actually surpassed it that you might not know of. I'll give you another example. Radio galaxies are a good example. They're so illuminated and they're full of radioactivity that, or radiation, you know, the electromagnetic sphere or spectrum. I think it's spectrum. You know, basically states that there's so much radiation in the universe that you're bound to run into something that large at some point. Stars just eventually come and go, but they outlive us, obviously. You know, there's so many stars, there's so many different types of, you know, there's just so much star mass out there and matter, material. It would have, I mean, if you can find that many black holes just somehow, and I mean, maybe it's possible they could have formed another way too, but basically from what we understand, that's one way to look at it, though, how they are formed. You know, it's mostly thanks to the illumination and the mass of a star, and then once the star implodes on itself because its gravity collapses on itself so badly and there's nothing really holding it together, so it creates an unstable force. That's just basically what happens. So that energy around it eventually goes somewhere else. And so if that's one way a black hole can form, and there are black holes that are so big, again, you know, maybe quasi-stars really do exist still, because maybe the fact that we're finding massive black holes that are just even bigger than our solar system, for example, I mean, it's possible, you know. But where would such a force lead, though? You know, why would, like, how is it that black holes get so big? And, you know, obviously they could merge with other black holes too. So it gets off that illusion that maybe it wasn't just from one star. It might have just, you know, because again, we have to really understand, where do black holes come from, how old they exist, and how they really work. You know, how do they, you got videos on YouTube of like people making like 3D animations of like two black holes merging, or like two protostars merging, or two, pulsars forming. And it's really interesting to think like how somebody was even able to like study something like that. These objects move so fast, and these objects move so, so, you know, it's like all over the place, like invisible, you know. Might not even exist technically. So I would say, I wouldn't be surprised if pulsar stars as well, or quasi and pulsar stars, are able to do what they do because of just the acceleration forces behind it. You know, it depends on how the universe really gives out its own, because everything in the universe is moving. Everything creates some kind of force. Like Albert Einstein stated with theory of relativity, reality is moving so much faster than we can perceive it. Doesn't necessarily mean it's a simulation, but it's basically like everything is creating some sort of heat, some kind of radiation. So if stars are obviously big balls of plasma and black holes lead to like other dimensions, you know, it's very possible that, or wherever they lead, it's very possible that they could have came from such a big star. You know, we found black holes that are way larger than, from what we understand, way larger than, you know, some of the biggest stars we know of. So if that's true, I mean, it's a good possibility to look at, you know, how quasi-stars could very well be what they are. Because there would be bigger, way bigger than Stephenson. It's like 1/4 the size of Stephenson, at least, or maybe 1/3 or something like that. It really depends. I have to double check. It's like between 25 to 33%, the 0.33% too, rounded. So basically, it's like you're looking at like big stars that, if it wasn't for their illumination and their mass, you're basically talking about how they very well could exist, and what other stars could exist between those spectrums and size and colors, because depending on the color they burn too, not just the luminosity, but the colors they burn. Like I'll give you an example. Our sun's white. It's actually not an orange, a red, or a yellow. It's just kind of gives off that distinct color in the between where it's at and the light traveling and mixing with the sky and all that. Like how we perceive with light and all that. The sun is really white though. So basically it's like the second hottest color. I always used to think white was the hottest color, but then I found out blue was. So blue is kind of like a cool, violent, not violent, but violent, like color it burns. And so instead of it being a cool color, it's more of a really, really hot color. And because it burns so hot, it obviously is right now, that's like the hottest star we found. And I mean, there are galaxies out there like ring galaxies and whatnot that have blue stars. I was always under the, and I'll be honest, this is where I'm kind of confused though, because I was always under the impression that the only time a star will change its colors is depending on how hot it is. That's really like the easiest way to look at it. It kind of sounds like a good star. But there have been cases where maybe that wasn't always true. Maybe at some point a star could have been burning so hot that it also cooled down too. There have been stars they found. I'll admit, yes, it's not going to contradict the way heat works. There are stars out there they have found where they are so cool that they don't burn at all. So their light source is very dim, but they're still a star nonetheless. It's almost like, because when you think of like the sun, for example, and mind you, we're still 93 million miles away from the sun at least, it still manages to find a way to get hot when it hits our atmosphere. So you got the luminosity of the sun being white, so it's very, very hot, second hottest burning colors, but it's like its size also has a lot to do with it too. And then meanwhile, they found stars that are shorter than our sun, but like, because they don't burn as hot, I think they're called brown dwarf stars, and they're so small, but at the same time so big that because they don't burn so hot, that the luminosity between them may vary. Actually, it has a lot to do with it living longer, because it's not going to explode. And then the temperature is like, it's burning like maybe between like 0 to 250 Kelvin or something like that. It's compared to like 1,000 or 100,000 or 10,000 Kelvin or maybe whatever it is in its core. It's crazy. It really is. Like just some of the stars and planets and galaxies they found, that just because of its property and whatnot, that we managed to end up where we were at. And maybe we really do underestimate the odds of how our planet works, and we really don't see it until we really think about it and compare it. But it really does seem like there is a lot more that could contradict the spectrum of like how many stars or what kind of stars are out there. And the same thing goes with quasi stars, So we might look at some of the stars we see now and think, we don't think that it could get any bigger than this. But we have proven that there have been stars that have came close to a lot of the stuff they do. And we have proven that the properties do in fact exist. Like, black holes do exist. And so I wouldn't be surprised if they still do exist, because obviously I'm sure there's bigger stars out there. Basically, a quasi-star would basically be a star that's so big that it found a way to do what it does. It collapsed on its core. But where would you find such a star? Honestly, I think if we were to take a luminous galaxy, a very, very, very luminous galaxy, be a good example. There's a good chance, because the higher those illuminations are, Either there's so many stars really close together, they're giving off the illusion that those stars are actually much brighter than they really are, and there are just so many stars next to it, or maybe the illumination is, maybe there's so many stars in that galaxy at the same time that they are, there's probably a lot of life in it too, possibly. I mean, assuming that the planets aren't too close either and the stars don't consume it. But maybe it's possible that there could be a big star there that's so big that it's a quasi-star and then eventually becomes like a super massive black hole at some point before its core collapse. Or maybe that was its core and then the rest of the star is gone. You know, it's interesting to think about. It really is. How large these objects can be, these celestial objects flying around in space, and nobody really knows what happened in the past, you know, or even what exists right now, you know, or does time even exist, you know, we don't know. So that's very interesting to think about. So quasi-stars are way bigger than hypergiants. So if there really is such a thing bigger than a quasi-star, that's going to be interesting too. It wouldn't surprise me, but it seems like until we discover something, it just, you know, we have to really keep our eyes open for something so massive, so far away. But again, you have the illusion of perception where, you know, you could find an object that's so big, but like at the same time, there could be a chance you might misjudge how big it is because, you know, when you zoom into something, it gives off the illusion of size rather. So, you know, it's hard to really measure objects from like far away, let alone, you know, even if it was up close. So that'd be interesting though, if somebody could find a star that really does exist like that. But I think black holes prove that the quasi-stars do in fact exist based on the massive size that they can create. So that I'll make more, if I find more evidence, I'll definitely update it. But as of right now, this is what I found so far. So it's kind of interesting. But yeah, if it is true, then this is what would happen. The black hole would still exist. And the rest of the light source, once whatever couldn't like break away from the black hole, would eventually get sucked in and then teleported wherever that black hole leads at what point in time it travels. Because black holes do move. And it's possible that as a black hole moves, it's creating other universes as well. It doesn't necessarily go to the same universe. I know that sounds kind of weird, but it is very interesting to think about. So I'll have to keep that in mind for another video, but it's interesting actually. Kind of makes me wonder, you know, what time period is the universe really in? If everything, you know, because we look at our time period based on planetary time, you know, 365 days, you know, as long as it's not leap year. But what I think is really interesting though is a lot of people seem to underestimate, like if everything in this universe is in the same universe, then what time period is the universe really in, you know? It really does make me think though. So again, subscribe if you're not subscribed already to this channel, and if you find this stuff very interesting, let me know. If you want to support me on Patreon, you can down below. You don't have to, but if you have any requests, let me know. I mean, I find this stuff interesting, and maybe we can learn a thing or two about some things that might exist in the universe that we don't, like maybe somebody discovered something that most people don't know about. Oh, by the way, I made a mistake. I think I said ton 680, but really it's actually ton 618, the black hole, the supermassive black hole that's in our galaxy that we know of. So that's actually very interesting to think. It's at least 40 times the orbit of Neptune, from the sun to the planet Neptune.